So sometimes you want to repeat a job forever, sometimes you'll repeat a job a set amount of times, and sometimes you'll repeat a job until the user or another condition has been met. So we're going to start off with a while loop. These are used for two different reasons. One, when you want to do something forever, and secondly, if you want to do something until a condition is met and you don't know when that condition is going to be met. So when you don't know how many times you want to do something necessarily. However, we will look at it in this case of even situations where you do know exactly how many times you want it to happen. So we're going to start off with while, and we just give it a condition, much like in a if statement. So in this one, it's a fairly odd equation here, while 1 equals 1. Now we've talked previously in a Boolean video about true and false. Now the while loop will run what's underneath it within the while loop as long as the condition is true. Now, does 1 equal 1? Well, yes it does. So it will run what's in the loop. Does 1 ever not equal 1? Well, no. And because 1 will always equal 1, this will always be true and we will always run what's in the while loop. So 1 equals 1 is just a really simple way of making a loop run forever. We could say while 3 equals 3. Of course, just 1 equals 1 is the simplest way of doing this. We could say while 1 is less than 5. All of those things will always be true. So let's have a go at making it do something forever. Let's just say that we want the computer to maybe just print hello forever. And at the end, just like we had end if for our if statements, we have end while. Again, we still use our indentation to say that everything in here is inside the while loop. And again, in this case, it's just for making it easy to read. However, like I've said before, in other languages, the indentation actually does make it clear to the program what part of the program is within the while loop or within the if statement. But for this time, you just need to appreciate it's just for arguably aesthetics, but you would never get a job if you weren't going to use indentation correctly. So if we do run this program, and what we'll find is a very exciting bit of program that just constantly is writing hello, 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 hundreds and hundreds of times a second, which will end. So we can do things forever, like so. Now, another example of that might be that we want to print rather than just the same thing forever. Why don't we get the loop to do something useful? So before the loop starts, I'm going to create a variable. Your variable could be called myVariable, not a very descriptive name. It could be called num, because it's just going to be a number in this case. It could be just simply x. Again, the most descriptive variables are the best. However, when you're doing something particularly simple, using a simple variable like x is fine. I'll call mine num, as it's just going to be a number. So I'm going to say that num equals 1 in the first instant. And rather than write hello every time, this time I'm just going to write the value of num. And we know that that's just going to be 1 forever. So again, when we run that, we're just going to keep writing 1, which is pretty boring, and we're just writing hundreds of them a second. What about if we wanted it instead to count for us? Well, we're going to need to learn a new word here called increment. So increment means to add on to each time, to increase. So we are going to say num equals num, if I could spell num correctly, equals num plus 1. So what does that actually mean? Well, we understand that this is setting the variable of num. In this case up here we said num equals 1. We're doing something quite different here though. We're saying num equals whatever the value of num was, add 1. So because num was equal to 1 in the first instance, it says 1 add 1, which now makes num equal to 2. So we go around the loop again, we write down 2, and then we say, right, well num equals 2 add 1, so num now equals 3, so we write 3. 3 add 1, so num equals 4, so we write 4. And of course, because we're at 1 equals 1, it will always do this. So if we wanted to count to a very high number as quickly as possible, this is a pretty much the tidiest way you can possibly do that. And you can see we're already up to 10,000 plus 20,000, etc., etc. So that's quite useful. And of course we can change what we do to num in here to try and cheat at maths and maybe find everything in the 2 times table or everything in the 49 times table or anything you really wanted to. So it's quite a useful tool, having the ability to loop forever. Sometimes we don't want to loop forever. Maybe I just wanted to print all numbers up to 100. In which case our while loop isn't going to help us very much here, because 1 equals 1 will always be true. Whereas we only want to print until num equals 100. Which in fact will give us a problem, but we'll look at that as we go. So we're going to say while num equals 100. Now in this case, does num equal 100 when it starts? No. So actually you're going to find that that doesn't run anything, because num never equaled 100. If we say if we want num while num is less than 100, so num equals 1. Is num less than 100? Yes. So we'll write what the value of num is, and then we'll add 1 to it. So num's value is now 2. Is it still less than 100? Yes. So can you predict what the last number that will be printed is? Let's have a look. And what you'll find is that the last number we print is 99. Well, why didn't it write 100? Let's have a quick look. So let's say we were on 98. Num equaled 98 at this point. So we say 98 add 1 equals 99, and num now equals 99. So while num is less than 100, well, num is less than 100. So we print 99, and then we say 99 add 1 equals 100. So num equals 100. And then we say, well, num is less than 100. Now num is no longer less than 100, it's equal to 100. So in fact, our right line will never happen here for writing 100. We could correct this by changing less than to be less than or equal to. And if we run our program again now, we'll find that because it will still run the while loop when it's equal to 100, that again is printed. Now while loops can be used for things more than just numbers. We can use them for maybe data validation. Data validation is where we want to make sure the user writes something incorrectly. And we can go back to some of our if statements to use this quite effectively. So let's say that we were going to ask the user a question, and so we'll start by asking the user, do you want to eat a, let's go crazy, penguin, why not? Do you want to eat a penguin? I feel you're all judging me now. And we'll give the user a chance to answer. So we need to store their answer. Eat penguin will have as my variable name. Noticing I'm still keeping with my camel hump style of capitalization, nothing on the first one, and then capitals for each letter following. Do you want to eat a penguin equals text window dot read, and that will allow the user to write in whether they would like to, yes or no. So I could say while the user doesn't write, so while eat penguin, what the user types in, while it does not equal yes, and spot my error here with yes, that the computer's going to think that's a variable, so I must put it in speech marks to make it realise we don't expect you to understand it as a variable, it's just something the user might type in, you don't need to understand it. So while they don't say yes, while eat penguin does not equal, again looking at this rather odd operator for does not equal, while eat penguin does not equal yes, we will do something. So why don't we say go on, eat the penguin. No, it's auto-completed for me. Go on. And of course that's going to be a text window .write line to be able to say it back to the user. So we need to put this in as well. Now this isn't going to be fantastic so far. Do you want to eat a penguin? If the user says yes, then this won't ever run. If he doesn't say yes, it will say go and eat the penguin, but then it will do something I didn't really want it to do. So if we say do you want to eat the penguin, I'm going to say no. Go on, eat the penguin, and it will keep saying it, keep saying it, keep saying it, keep saying it, keep saying it. At this point the user never gets an opportunity to change their mind and that they're going to eat the penguin. So we're going to try and modify that slightly by copying these two lines of code here and pasting them in here as well. So what happens now is once the user has said anything but yes, it will run this loop. So it says go and eat the penguin, and then it asks then do you want to eat a penguin, and gives the user another chance to type in yes. What's the downside to this? Well, we have got duplicated code. These two lines of code are the same as these two lines of code, which isn't a great thing. And in a lot of programming languages we have what's called a do-while loop, which is where it will run a job such as this the first time, and then it will request, then it will run it every time that the condition returns true. But in this case it solves our problem quite nicely. So it can say do you want to eat a penguin, and I can quite simply say no. Do you want to eat a penguin? No. Go on, eat a penguin. Do you want to eat a penguin? Fish. Doesn't really matter what I type in as long as it's not yes. Do you want to eat a penguin? Yes. And then the program says press any key to continue, and the program's finished. So while loops can be quite effective, this can be quite useful, for example, if I wanted to check to make sure the user had responded one of the responses I wanted. For example, while eat penguin does not equal yes, and I'm going to say, and we're going to use that keyword and I'm going to say while eat penguin does not equal no as well. So we're basically saying the user must type yes or no. If they don't, we'll say you must choose yes or no. We'll ask them the question again and give them a chance to answer. So this is just a way of doing data validation, making sure that the user either gives us yes or either gives us no. Do you want to eat a penguin? So if they say monkey, it doesn't say it. If I say YE, it says you must choose yes or no. Do you want to eat a penguin? Well, I could say yes. We could have a problem where the user types in yeah, for example, but then this nice little reminder to the user that they must say yes or no should solve that problem. We could of course allow for yeah by adding another statement saying while it doesn't equal yes, and it doesn't equal no, and it doesn't equal yeah, and it doesn't equal definitely not, all these kinds of things. However, hopefully this is a good starting point to help you with a bit of data validation.